Hi, so now we're going to be talking about file systems and how they are implemented. So, in essence, just like most things, files are just an array of bits, right? Um, Everything in memory can sort of be assumed to be sort of like this one gigantic array of bits and bytes. So, array of bits. So when we think about files, right, the way there's sort of three ways that we think about it. So the first way is the most intuitive way, which is like the human readable way, right? In which we think of file as like a path, right? And this would be, like if you have your documents folder and in it you have hello.txt, right? This is how we think of it. We give files a name and then we give it a path of where it's located under which directory, and this is the human readable way. But then there's also the runtime definition of files, right? Which is a file descriptor, right? This is how we define it when we are programming, right? When you, when you call fopen, the result of which gives you a file descriptor, which is like an integer, sort of gives you where this file is located, right? And then the third definition is the low-level definition of this. This is how our computer views the files, and this is through something called an inode. So an inode is just a unique identifying unique number which is assigned to whatever file that we have created. Every file will have its own unique number. When files are deleted, eventually these numbers will all be replaced or recycled, sorry. But I do think it goes through and assigns it accordingly. So, and then real quick, while we're on files, we'll also go over directories. If files are an array of bits, so are directories. They're also an array. They can sort of be thought as files themselves, sort of like files. It's just the information that they contain is a list of pairs. So they contain a list of pairs. Which consist of, like, this human readable path name or file name, and then the inode value, right? And then sort of like traversing through a directory to find a file, like if you're in like the root directory and you want to go to document and then you want to find hello.txt, what you would do is you would go to the root directory, find the inode that's correlated to doc, right? Your documents. So document is the name of like the path, and then inode would be like, say this is somewhere number 137, right? So then it would go to it would find inode 7. We'll talk about how it does so in a bit. And then it would go, and then it would find out that, oh, document, this is another directory, so let me traverse again, go through the list of pairs that are listed under the document directory, and then find the appropriate file. So in terms of how it's represented, so we'll just draw memory as a big array again, like this. We can just assume that this much is allocated for data, and this much is allocated for inodes. And so yeah, so this is how it would look like. So when you go to inodes, right, this is like the part of memory in which all like the file inodes and all the directory inodes are stored, right? So the way this works is that each inode, like say the inode at index 1, it contains information like type, like is this a file, is this a directory, right? And then also looking at how big it is, right? Size, how large is this, and then lastly the most important thing, which is how much where is the data located, right? So we want to look at, you know, let's just say 2, 3, 4. It's 4, right? So this it'll contain a list of addresses, like if it's like a and it'll contain like, oh, and this position is where you will find the data that's associated with this file / directory. And then real quick, so when you do all of this, you can find it. I really don't feel like remaking this video, but my brain is freezing right now. Actually, let's just go into, and then this part over here, this one block here that I left out, this actually contains the metadata. It just like how inodes contain about whether this is a file or directory, what the size is, what the data is. This contains information about where all the free blocks are, because, you know, like if some data has not been allocated, it contains information about the size of the inodes / data, like just how the inode knows that, oh, I have one block of data, right? One block of data, and it's at block 4. This also keeps track of the size of inodes, because these are like files, right? Like how many files are we creating, how much space are we taking up. So this is what the metadata is for. So let's sort of look into how like a directory is created. So let me draw this array again. Right, this part can be data. We can have 3 inodes, and then this is the metadata. So when and let's just say we're trying to create a directory called foo bar. Like foo is the first directory and bar is the second directory. So we're trying to get to this directory and create it. So we're doing a make dir make directory. So what happens sequentially? So first, what would happen is, since this is located at the root directory, there's always one associated with the root. So you would go to the root inode, and then you would ask for where the data is, right? You would go to the root, you would figure out that it's a directory, and and you figure out where its data is, and maybe its data is right here, and then you go access the data here, and then you ask, oh, where is directory foo, right? And you're going to go through all of the lists, all the pairs in that list, and then you're going to figure out foo, and you're going to find out that foo is at location 2, right? This is 1, 2, 3, right? So location 2. So now you know where that is. So now you're going to go to foo, and you're going to say, oh, where is your data located? And again, we figure out that it's a directory, and its data is located at 5, right? And this one was at 4. And then you go to location number 5, sorry. And then you go, okay, where is bar? Because we want to make a directory, and this is also to prevent, you know, like duplicate directories from being made. So you're going to check, and you're going to ask, oh, where is bar? And then you're going to go through the list, and you're going to find out that, oh, it's not there, right? So what to do now? So now you're going to go to this metadata, and it actually has 2 lists. So first you're going to go to the inode bitmap, which contains all the free spaces that you can use to create an inode. And you're going to ask, could I have some space to create bar, right? And then it's going to say, okay, you can go to space 3. That is the first free available block to create an inode. So then you go to 3, and then you create a bar here. And then while you do this, you also go and you ask it for, you look at its data bitmap, and you're going to ask for it to assign some free space to store your data, right, for this directory. Right, and it's going to say, oh, go to position 6. So then you're going to go to position 6, and and you're going to say this is bars, right? And you're going to assign it B. And yeah, so next time if you want to like make a new file or make a new folder, you would have to always ask the metadata for where the free space is available and where you can insert your inode and where you can insert your data in. And this is sort of the way files are positioned. If you want to, and yeah, occasionally you will also have files which point to multiple data nodes. So depending on, if you increase the size of the directory suddenly and it can't hold all of the data in one block anymore, it might be assigned 2 blocks. So if you ask for data, it'll say, oh, it's at 5 and 7, and then you may have to look at both. So depending on how things work out, there might be multiple data blocks that it's pointing to. And yeah, so this is how the file system works.